So we're here at ARM Techcon here at Cadence. So what is the latest?
So Nicholas, let me just show you the latest that we've got. So today I just wanted to talk to you briefly about the 40 nanometer press release that we have with ARM and IBM. This is really one of the first announcements that you'll see on a 40 nanometer ecosystem work that we've been doing. And this press release was really talking about a Cortex-M processor that was implemented using IBM's FinFET process technology using Cadence tools. So it's a really huge industry challenges you're seeing being solved as you see these sort of test chips being taped out on 40 nanometer.
So this is taped out, it means it's for real.
It is. Well, it will be for real. That's correct. Yeah. We are expecting it to come around. I think it's Q2 next year. So I need to check on the specifics of that, but it's certainly going to be a real test chip.
So you work with IBM, you work with ARM, you work with who do you work with?
We work with multiple ecosystem partners. So IBM is obviously one of them, but we also work with a lot of the other foundry partners as well.
So the products you make are software development. What is it?
So what does Cadence do?
Yeah.
So we actually make the software technology and some of the hardware technology that actually allows customers to design their SoCs, some of the complex SoCs that you see today. And really what we're doing with the work with IBM and ARM is pre-validating some of this challenging technology to prove that it does work in the real case. So that's exactly what we're doing with ARM on 14 nanometer.
And over there you're talking about, what is this over here?
This is very exciting work we're doing here. So this is on a very slightly different area. Here what we're doing is ARM's smallest processors are the Cortex M0 Plus chips. And really what we're looking at is typically enabling analog customers who wouldn't have used a digital Cortex-M processor before, and making it very simple for them to be able to actually design that Cortex-M processor into their mixed signal design. So maybe what I can do is hand you over to Malodin and he can talk you through it.
So what are you showing here?
Hi, Nicholas. We have a system for controlling fuel pressure in automotive, an example of this prototype basically. So we leverage ARM Cortex M0 development studio, system development kit basically. And we added to that analog peripherals, including A to D and D to A converters, pressure sensor and regulator. Now, based on the code developed for the Cortex M0, we use the RTL and instruction set, tied it all together with the models, high-level models for analog peripherals, so that chip and system designers can do actually full system simulation in a very short time, and test basically that the code and system will function properly before they move further to implementation. As you see here, we have one of scenarios where we basically test also how the chip reduces power consumption. In this case, when the pressure is stable, then we send Cortex to sleep basically, so that it reduces leakage and active power. And as soon as something changes in the system that require Cortex M0 to wake up and readjust the system, it does very quickly. You see, in these small intervals, uses fuel cycle to again put the pressure at the nominal level.
So there's waveform, SimVision and Virtuoso?
Exactly. So Virtuoso schematic editor, there's a Cadence tool. This is our cockpit basically to run set-up all simulation, and SimVision is tool where we show the results. Behind all simulation engines, net listing, and other tools that support what you see here.
So those are two applications of the many applications that Cadence does, or?
That's correct. That's
and
correct.
Are used by chip designers.
Oh, they use exactly. They're used by many chip designers all over the world.
It's running on Ubuntu.
Here on Linux, but also there are other real support or other operating systems.
All right. Cool. So what's going to happen in the future? What's next?
What happens in the future? So actually, I think if we look at the embedded processors for a minute, there's actually going to be an enormous amount of design activity within that space. So if you think about, ARM's been talking a lot about the Internet of Things and how there's going to be, billions of devices connected to the Internet. I think that's one of the things that we really are focused on here today to enable that activity to take place. So if you look at customers who typically design purely analog-only components, very challenging IP in that area, what ARM is doing with their Cortex-M processors is allowing that analog component to be connected to the internet, and that can feed its information back and be part of that bigger ecosystem.
And so there's big little, there's
So yeah, so Big Little is also conceptually very interesting from ARM. As you know, that manages performance and power trade-offs between the two processors. The reason why we're talking about this here today is that we have both excellent implementation background with a lot of implementation information around Cortex A7 and A15, which makes up the Big Little pair to work in a Big Little system.
So also you have Cortex A POPs. What is that?
So yeah, I just want to talk about the POP IP and the work that we've been doing with ARM supporting that. So POP IP enables customers to very quickly go time to market with challenging Cortex A implementations. What we've been doing is we've been working very closely with ARM to further enhance that time to market so that customers with challenging implementation times can work with Cadence tools with ARM's POP IP, and that dramatically shortens their time. So it really helps them achieve known PPA goals in their design by using the IP from ARM and Cadence toolset.
So POP means what is it?
Well, so it's slightly changed. It really is about a processor optimization package, but really it's a whole package of IP that you buy from ARM, and it would run on top of Cadence tools to really shorten that time to market and guarantee or certainly ensure that you meet a performance, power or area number.